Hello, this is Mr. Rasmussen with Algebra 1, Lesson 94. This one is back to our distance problems, and if you remember back to Lesson 92, we were given our first scenario, which is where a distance is equal to a distance. It's where something goes the same or goes there and comes back in the diagrams there, and we said that was equal to a rate and a time is equal to a rate and a time. Today we look at a second situation, and in the pictures that would look where maybe two trains start at the same place and they go opposite directions, or they start at two spots and come together and meet. And so the way this looks is that the distance of one plus the distance of the other is equal to a total distance. Okay, so if we take the distance out and put that into our rate and time, we get rate and time plus the rate and time is equal to a total distance there. A total distance. So let's look at example 1. And you can see how this gets put together. It says a southbound bus left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. If the buses traveled at the same rate and were 352 kilometers apart at 2 p.m., find the rate of the buses. So we want to know how fast in kilometers per hour are they going. What are some things that we know? Well, let's write them out here. Let's do the time of the southbound bus is equal to, well, if it left at 9 and we took the record at 2, that's equal to 5 hours. Okay? The time of the northbound bus, it left 2 hours later, so that's 3 hours. The rate of the southbound is equal to the same rate of the northbound bus. So there's the information that we have to work with. So since they're starting at the same place and heading in opposite directions, our pictorial, here's the starting point, looks, well, it would be north and south, so it'd be up and down, but I'm going to write it horizontally. Looks like that. So let's write it out here. We have the rate of the southbound bus times the time of the southbound bus is equal to the rate of the northbound bus times the time of the northbound bus. Oh, I messed up. All right, that's the first scenario. We have the second where we add them together, and that's going to equal the total distance, which we're told is 352 kilometers. All right, let's fill in some information. The rates are the same, so let's pull down the rate of the southbound bus. Let's substitute the rate of the southbound bus for the northbound bus since they are the same over here, substitution. All right, the time of the southbound bus is 5, so put a 5 here. The time of the northbound bus is 3, so now we have our equation set up. These are no different as if they're written in the front here, so I'll write them in the front, a little more intuitive. All right, we have 5RS plus 3RS gives us 8RS is equal to 352. Divide both sides by 8. And we get the rate as 44 kilometers per hour for both the buses. That's for the rate of the southbound bus and the rate of the northbound bus because they're both going the same distance or the same speed. Okay, let's look at example 2. Example 2. Once again, we got a train that starts from Toledo at 11 a.m. and heads to Mackinac, 332 kilometers away. At the same time, there's a train that leaves Mackinac and heads toward Toledo at 65 kilometers per hour. If the trains meet at 1 p.m., what is the rate of the first train? Okay, so let's do the time of the first train leaving Toledo, leaves at 11 a.m. and they meet at 1. So it looks like that one's traveled 2 hours. And then it says at the same time the other train leaves. So train number 2, or the time of number 2, is also 2 hours. So they have the same time for both of those. All right, we're not told the rates of the first train. Don't know what that is, but we are told the rate of the second train is 65 kilometers per hour. So if we put this into a picture, we've got Toledo here, and we've got Mackinac here, and the two trains are headed toward each other. Okay, so if we see that, that's equal to a total distance. So we have the rate and time of the first train plus the rate and time of the second train is equal to our total amount, which is 332 kilometers apart. All right, let's fill in some information. The time of the first train is 2, the time of the second train is 2. The rate of the first train we don't know, so we'll bring that down as our variable. The rate of the second train, parentheses, its multiplication, is 65, and then bring that down. All right, we have 65 times 2 is 130. So 2 times the rate of 1 plus 130 is equal to that. Subtract 130 from both sides. We get 2 times the rate of 1 is equal to, looks like 202. And then divide by 2, divide by 2. It looks like the rate of the first train is 101 kilometers per hour. Okay, I hope that kind of makes sense where we select the correct equation as far as the scenario, and then we plug in our information and we solve it. Okay, I'm going to work through the 2 practice problems, and I really encourage you to try these and then check your work to see if you've got it. So, practice problem A has 2 buses. An eastbound bus that left Uka at noon, and 2 hours later a westbound bus left the same station. If the buses traveled at the same rate and were 500 kilometers apart at 6 p.m., find out the rate of each bus. So how fast were they both going? So once again, we've got a station here. One's going one way, one's going the other way, and that's equal to a total amount of distance. So the rate, we'll put in the rate of the eastbound bus and the time of the eastbound bus plus the rate of the westbound and the time of the westbound is equal to our total distance of 500. All right. We don't know the rates for either of them, except we do know that they're the same. So let's substitute the rate of the east in for the west, since they are the same. Could be done either way. All right, the time of the eastbound bus. It left at noon, and then the record was taken at 6, and so that's gone 6 hours. The westbound bus left 2 hours later, so that's only traveled 4 hours. Okay, if we add those together, we get 10 times the rate is equal to 500. Divide both sides by 10. It looks like the rate of both the buses is going to be 50 and kilometers per hour. All right, 50 kilometers per hour is our answer. Rate for both of them. Okay, practice B. We have trains. Trains start from Peoria at 2 p.m. and heads to Reedley, 750 kilometers away. At the same time, we have the one train leaves from Reedley and heads back to Peoria at 85 kilometers per hour. If the trains meet at 5 p.m., what is the rate of the first train? Okay, once again, we have the rate and time plus the rate and time is equal to a total distance. Total distance in this case is 750. Let's put some labels in here. Let's do train 1 and train 2. Okay, for train 1, we don't know the rate. We're trying to find that out. What's the time? It says it left at 2, and we took the record at 5, so it's been traveling 3 hours. The rate of the second train is 85 kilometers per hour, and the time is, once again, it left at the same time, so that one's also 3. Okay, so there's our problem. It's set up. 85 times 3 is 255. And let's subtract that from both sides. So we get 495 over here, and we bring that down, divide both sides by 3, and it looks like our answer, the rate of the first train, is a bit faster than the second train. It is 165 kilometers per hour. Okay, I hope that went well for you. Please feel free to reach out if you need some assistance, and have a great day.